Today we're going to look at how to calculate the number of protons, neutrons, and electrons in a neutral atom such as you would find on the periodic table. So we're going to take a look at sulfur, and sulfur has an atomic number of 16 and an average atomic mass of 32.07. The average atomic mass is a weighted average of all the isotopes, and we're going to come back and look at that in another video. But we're going to look at right now is how to find the number of protons, electrons, and neutrons. So quite often you'll see a problem could be in a textbook or on a test, and we'll have sulfur, and the most popular isotope of sulfur is 32, and so this is the atomic mass. Notice it's a whole number. Now, quite often when you do problems of this, your instructor may say, round it up, round it down to the nearest whole number. And so we have the atomic mass, and this is the atomic number. Now, for a neutral atom, the positive charges have to equal the negative charges, or the negative charges have to equal the positive charges. But in protons, if you remember right, have a positive charge. So the atomic number equals the number of protons. The number of protons is the identifier of the element. It's like the fingerprint. It doesn't change. If you see an atomic number 16, it's sulfur. That does not change. You change the atomic number, you change the element. So the atomic number equals number of protons. So for our example here, we have 16 protons. Now in a neutral atom, the atomic number also equals the number of electrons. Now we'll come back and look at charges later, but suffice it to say for right now, the atomic number equals number of electrons. So our atomic number for this particular example is 16, so we will have 16 electrons. That's kind of the beauty in the periodic table. You can always find the atomic or the number of electrons by looking at the atomic number. So what we're left with, we need to determine the number of neutrons. So the number of neutrons, let's see. Number of neutrons is going to equal the atomic mass minus the atomic number. So for our example, we have an atomic mass of 32. So we're looking for the number of neutrons. So our atomic mass is 32. Our atomic number is 16. So our number of neutrons is also going to equal 16. Now, this won't always be the case, but follow this formula. The atomic mass minus the atomic number is going to give you the number of neutrons. Let's do one more problem here. Let's look at lithium. And let's say that lithium, most common isotope, has a mass of 7, and lithium has an atomic number of 3. So this is the atomic mass. This is the atomic number. So we know the atomic number tells you the number of neutrons, or excuse me, number of protons. So the number of protons equals 3. Therefore, for a neutral atom, the number of electrons have to be the same. The number of electrons equals 3. So we're left with, we need to find the number of neutrons. So the number of neutrons, as you recall from above, so the number of neutrons equals the atomic mass, which is 7, minus the atomic number, which is 3. So that's going to give us number of neutrons is 4. So we have the atomic mass, which is 7, and the atomic number, which is 3. Remember, the atomic mass is also found in the nucleus of an atom, and that's, again, it's the number of protons and the number of neutrons is going to give you your atomic mass. So, hope this helps, and we will see you again.